So yes, thank you for being here. And yeah, let's start without any ado. So the talk is simplifying real-time 3D app development with React. So what does that even mean? Before getting into that, like a little introduction, if this works. Yeah, there you go. So my name is Houssem. I qualify myself as a systems engineer, and I'm also on my spare time like CTOing and the co-founder of 3Dverse. Whatever CTO of a startup means, that's what I'm doing. My background is in the video gaming industry. So I've spent like the majority of my career making video games. Like those are the titles I worked on. I also did a little stint at Apple working on the Apple Vision Pro, and my work has always been geared towards like real-time 3D engine optimization. So nothing to do with React, I fear. So, but before you start throwing stuff at me, let me actually, before even that, let's start. I want to know like how many of you know about real-time 3D. So Unity, 3GS, by show of hands, yeah, like really worked with it, made stuff, tried to deploy it, not just know about it. So show of hands, two over there, that's it. The other you just heard about it. Okay, so for those who worked with it, this might give you another way of doing stuff with real-time 3D. For the others, this might you might learn like a new way of using React to make other kind of web application. So let's kick things off with a live demo. And this setup is a little bit experimental. So yeah, thank you. So this is like a web browser embedded in PowerPoint. So I'm trying this out for the first time. So this demo here is using 3Dverse, like what we are developing inside. And we're going to showcase the kind of application that we work with. If it... Okay, I was testing this like 5 minutes ago. And it's, okay, never mind. I can... does it work? Yeah. So let's get... Oh, it worked. Just a little bit at time. You go back where I was. Where's my... So here you have, this app is running in the browser. I'm controlling the character. Here I can emote with him. Hello. Oh no, that's rude. Please say hello. Say hello. Yeah, hello. And this application is natively collaborative. So anybody can jump in. I have Alex over there. Like he's just over there. He's going to join me, and he will appear right there. He's there. Yeah, hello. That's rude. So yeah, so this is basically what we're doing in 3Dverse, developing this kind of application. So this is just a gimmick, like a game application. But believe it or not, this is a React app that is about 100 lines of code, like of React code. So let's. Nope. I want to. How can? Yeah. Yeah, and this is running on PowerPoint, like. So. It actually blew my mind when I. That's good. All right. So a little quick agenda of the rest of the presentation. Basically, this whole presentation is about our journey on how we develop like all the tools to allow developers that are not necessarily knowledgeable in 3D development to be able to create easily those kind of application. And in doing so, we wanted to, and basically we use React to improve the developer experience, because we were using vanilla JavaScript, and it was very, very hard, sorry. And by using React, we made it like a breeze. But before going to the details, like as Patil mentioned, we define ourselves what we're building at least, as a cloud-native real-time 3D operating system. So that might be a little bit overwhelming, and it actually is. But let's unpack this like step by step. So starting by cloud-native, what we mean by cloud-native. So obviously it runs on the cloud. That means that everything, or at least mostly all the processing happens on the cloud. On remote servers, nothing happens on the user's device. That meaning the data is on the server, the processing is on the server, and even the rendering is on the server. Nothing happens on the client's device, which means that it's accessible from anywhere. So basically, you only need a browser and obviously an internet connection. And it's scalable. That's the usual cloud benefit. You can increase or decrease your resources depending on the workload that you have. So basically, if you need to like keep only one thing in mind, is everything happens in cloud. Like that's basically it. Now for the real-time 3D part. By real-time 3D part, we mean mostly it's like interactive. When you move your camera, you move your mouse, it's instant. You get an instant new image. It's not offline processing, it's not offline rendering, everything happens live. And it's also streamed. As I mentioned, everything is running remotely. For if some of you remember like the defunct Google Stadia, it's basically the same technology. You could run it on your technology, not the same business approach, hopefully. And we mean also high fidelity in the sense that no matter the device, you will get the exact same experience, the exact same quality of experience. You don't need to degrade your data or whatever to get the experience to the end user device, because as I mentioned, nothing happens on the end user device except like video decoding. And now for the big one, like operating system. Why did we choose that word? Because a very heavy word. By that we mean mostly that the whole management is centralized. So we take care of everything. The data, like it's a unified platform that handles managing, sharing, deploying the data and your application and everything. You basically don't need to care about anything but your end solution, your business solution, basically. It's also collaborative by design. So it has multi-user collaboration built in the core of the platform. So it's not an afterthought like in many other solutions or something that you need to build on top of it by yourself. It's just by design, it just works. It's if you can run it once, you can from one user, you can run it from like multiple users at once. And above all, it's extensible, so you can use it to build your own either extension or full application, etc., etc. So hopefully that clarified a little bit what all that meant. So to illustrate that a little bit, so we have like a little video here that shows some use cases. So this showcases real-time collaboration when you can see multiple users interacting in the same scene. So here you have like the first user drag and dropping, modifying stuff. There are two you can see on the top right corner, the two users. So here it showcases the device agnostic part, some other industrial manufacturing use cases with digital training, etc. And everything you just saw runs on the browser, by the way. Like there's no app, nothing to download, nothing to install. Go to the URL, boom, you're in business. And yeah, this is a fun one when you have an actual physical robot that is connected, which is called digital twin. Basically, it's connecting directly to the 3D rendering and sending data at real time. And yeah, interactive, you can, this is a underwhelming ending of that video, but anyway, that was what this cloud native real-time 3D operating system is all about. So now that we have you hopefully have a better overview of what we're talking about, let's get dirty and go inside the belly of the beast. So this is basically a very high level overview of the architecture of the whole platform. So on the top right corner over there, you have all that cloud native stuff. Look, you have your Kubernetes, your microservices and whatnot, databases, etc. On the bottom part here, you have your real-time 3D with the engine running on virtual machines and a hypervisor managing everything. And sorry, I skipped a part. What was I going to say? No, and yeah, all the arrows, and it's basically what the OS is. It's all the interaction between, like, orchestrating and managing the interaction between all those systems. But what interests us today lives here in the delightful userland. So this is where the user interacts with the platform. And they need a simple web browser. Going inside that browser is our web application. So our like 3 powered web application. So that application is should look very familiar to you. It's basically all web technology. So you have your trifecta of HTML, JavaScript, and CSS in the middle, and then all the framework you can imagine or you can use. We don't really have any limitation on that. But you can notice, like, in the middle of it all, there's this thing called LiveLink. So LiveLink is basically how do you call it? It's a name we use for a collection of libraries, say, and our protocol, our communication protocol. It's basically the beating heart of the 3Dverse application. It's mainly composed of what we call LiveLink core. LiveLink core, to get it like in simple terms, it's basically the implementation. I don't know if that's simple, but it's the implementation of the protocol that is based on async API, if anybody knows that. So it's just like OpenAPI, but for async communications. And its main role is communication with the 3Dverse, with the 3Dverse server. It uses WebSockets, raw-based sockets, and it's just concerned about low-level networking, serializing, deserializing stuff, and making things digestible for a higher-level application. So we have that core, and we've built around that a wrapper that we call LiveLink.js, which is actually written in TypeScript, and is a kind of a user-friendly wrapper on top of that protocol, and it adds on top of it all the utilities to handle like the viewports, the cameras, the canvas, the decoding as well, like decoding the video, etc., etc. So that's all what's called LiveLink. Those part of what is LiveLink. And just to showcase a little bit what I'm talking about, because I've been talking like feels a very long time. Let's see how a simple app is made. So it's a little bit blurry, but you can see here, this is running in the on the browser. You have your 3Dverse canvas powered application on here. It's if you can read, like, there's a body, a div, a canvas. That's it. That's all you need basically to build this kind of app. And code-wise, because JavaScript-wise, what's happening, using LiveLink.js looks something like this. So this is the actual code of the app you just saw, and it's so it's loading dynamically the the module here from Unpackaged, and it's doing a bunch of stuff. So it's doing codec, instance creation, getting the rendering surface, creating viewports, creating cameras, and everything is very verbose and it's very error prone. And there's basically no state management. It's LiveLink.js just gives you very fundamental pieces of building blocks. So we've worked a little bit with this, and it was very painful and very not developer friendly, because we've built it, we know how to use it, it was fine, but when new people started coming on and trying to use it, we found out that, yeah, it wasn't that user friendly. So what we decided to do is, yeah, here, React. Here comes React, LiveLink React. So LiveLink React is basically our wrapper on top of LiveLink.js using React. So exit all this vanilla code. Actually, let's get it back here and in full. So those are, I don't know, I think it's around 100 lines of code. And let's see what the exact same application looks with LiveLink React. There you go. And that's it. It's basically a couple, I don't know, 10 lines, and everything is well wrapped, is well, I mean, even somebody that doesn't really know how anything works but knows a little bit about 3D can understand what this app is doing. So let's go ahead and like analyze everything, like every component that we've built and how we built it, and what did it basically help us to achieve. So first, we started by simplifying the connection lifecycle, because with the old way of doing it, it was very, as you saw, like everything was manual, the state management, etc. So what we've built is just a very simple LiveLink component, which which acts as well as a context provider, and which handles all that management for you. So all you need to do to give it is a config, scene ID. I didn't mention where the 3D come from, by the way. But you can think of it as an external resource, like you will load like an image from a distant server. It's the same thing. You just give it the URL of that image. In 3Dverse, it's the same thing. You have a scene ID that you can generate in various ways by uploading some files or creating from scratch with other ways, and then you get that ID and you use that ID in your app, and it loads it as you saw. So you give it some information. You give it even some lifecycle kind of optional components like the inactivity warning or the connection error, which are like UI panels that pop up when the user is inactive for too long, etc. So everything is like way more easy to reason about. So as I mentioned, the LiveLink is a component, and it provides the context providers. So all its children has access to the what we call the session, basically the connection with the remote server, to send messages and receive events. And we added as well a hook for the clients. What clients are basically just people that are in the same session, because it's collaborative, multi-user, etc. So when Alex joined me, we were 2 clients, and this use clients hook, I don't know what's the proper React terms, but triggers whenever a new clients come in, so you can update your UI with it. So that's about the connection lifecycle simplification. And the big one, next one, is layout manipulation. So when you have like a video game, it's fairly easy. You just have one single viewport, and you have your game running in that viewport. But when you have more, how do you call them, like digital twins or business-related applications, you start needing to have multiple viewports. Maybe you have a viewport to like a picture effect to see the point of view of the other user. You might have like 4 viewports to see from different sides your object or your model, etc. So handling all of that was a little bit complicated before. So we introduced those 3 components, which are the canvas. The canvas is an HTML canvas. It's just a wrapper around the HTML canvas, and it has as well, it can take children. So, because there's a little bit of a problem we hit when working with this, is that the canvas, the HTML canvas, cannot have children. So we created this abstraction that can get to children and reposition stuff around with CSS, and for a user, it's just parenting stuff. And underneath the canvas is the viewport. The viewport is basically a slice of your canvas. You can have a single canvas and then split it up in 2, 3, whatever, however you like viewports. And finally, we introduced as well, like as an experimental feature, the WebXR component. That component, if you use it, you basically, I don't know how many of you are familiar with WebXR? 1, 2, 3. All right, so for the others, WebXR is the way that the browser provides to like the app to get into a AR context. So augmented reality or virtual reality. So when you are using a VR headset, you can go to the browser, and if you have an app that is WebXR compatible, it switches the context from the browser to the actual XR environment, and you are in the immersive world. So with this little component, this like a one-liner in your web app, if you mount, whenever it mounts, it creates a WebXR context and switches completely your context. It goes outside of the browser, gets into the XR, and you can experiment the scene that you just saw in virtual reality with your headset, which is pretty neat. Like for a one-liner, it's pretty interesting. And there's a lot of use cases where you need to put into the 3D world, you need to put some 2D elements, like a panel for more information, or even whatever you want, like, but that is not the proper 3D. So we created those 3 components, 2 components, to act as an overlay. So this, basically what they do is like they create a div, position it on top of the canvas, or the viewport more precisely, and allows you to add more elements to your 3D scene, but those elements are backed by actual HTML components. So divs, like in the example here, you have canvas viewport, DOM overlay, DOM 3D element, you give it a position in world space, so in your 3D world, and that paragraph will show up right in your 3D scene and move and rotate with your camera. We also added a 3 overlay for to compose with a 3JS scene. So you can have your 3JS scene in 3D and your 3Dverse scene and have them like using the same camera projection. And yeah, and the DOM 3D element is basically the little component that allows you to put everything in the 3D world. And next stop is how to simplify user interaction. So in 3D, user interaction is mainly controlling the camera. So you have a camera, and that's how you interact with the 3D world. You move around, look around, that's it basically, and click stuff. So for that, we introduced a hook called use camera entity. that basically is able to either fetch an existing camera. What we mean by camera is basically all the settings related to the camera, like the field of view, all the graphics settings, a lot of them. And with that hook, you can either fetch a pre-existing one or create a new one by specifying its position in the world and the settings that you want. And we added also a camera controller. So the camera controller is what represents so we added as a component first because it felt like, as I mentioned, a UI related component, right? Because that's how the user interacts with your application. Except it's not backed by any actual HTML element whatsoever. And we had a little problem with that because usually the application, they will have a side panel where with control buttons when you like go to a certain point of interest, and then you have your camera travel around, etc. And to do that, you need to access to the camera controller. But accessing that camera controller, as it's nested inside the viewport, was a little bit cumbersome. You had to create a state inside the controller, have this a callback. It was a mess. So what we found out is this. I mean, it's probably nothing new for you, but for us it was new. This forward ref stuff, and I know it's like deprecated in React 19. I think it's by default on the components, but we're not using React 19. So it's this forward ref thing. It's used usually to just forward a ref of a DOM element. But if you use it in conjunction with this use imperative handle, you can basically reference any kind of object that you have in your layout, even if you don't have an actual DOM element. So it's very. I mean, it's very useful as you can remove all that hassle to manage your own state. You just use ref and forward that ref to any components that is in the same like a subtree. And finally, we have the simplification of world interaction. By world interaction, like in 3D, you have what we call an entity. An entity is basically something like an object. It could be like visual, having a proper geometry, a mesh, and an existence. But it could be logical, like a light. A light doesn't. I mean, it emits light, of course, or a script or whatever. It's something that exists in your 3D scene. And for application, it's very important to be able to easily interact with those entities. So we introduced this use entity hook that is able to basically either create or search for an existing entity, again, depending on the parameter you give it. So for example, in this scene here, this example, we have a light in our scene. It has that ID. And with that, you can do basically, you can modify the entity. Basically, you can add UI to change the light, change the intensity, change the cutoff if it's a spotlight, etc. And to simplify using the UI stuff, so if you can use this component that's called DOM entity, which acts a little bit like it's basically a DOM 3D element, but that is hooked with an entity. And instead of providing directly the position of your DOM 3D element in the scene, you provide the entity, and the DOM entity component will just extract the position of the entity. And so if the entity moves, your UI moves along with it. So that's basically LiveLink React for you. The gist, like, it's everything that LiveLink React provides. And to finish, I can show it in action and see a little samples of like everything that I just mentioned. If I figure out how to get out of here, where's my mouse? It's over there. Mouse. All right. So no. Yes. Do I have another screen? Yeah. All right. So there we go. And I don't see it here, so this is going to be fun. Where's my mouse? All right. So this is basically the kind of what all I mentioned is the samples. It acts also as tests for us for all that we've built on the LiveLink React. So here you can maybe not. Let's check this one. Oh, I didn't mention as well that everything I just meant, the whole layout thing is composable. So you can have a viewport inside the canvas that itself inside the canvas, so you can create stuff like this. So here, for example, we have two canvases, the right one, left one. Each canvas has two viewports. The first one is split horizontally, the other one is split vertically, and each one has their own camera. Where's the? Oh, it's there. And the code part of it is, as I mentioned, is over there. So you have your canvas, your viewport. Inside you have the camera controller, and you have that like 1, 2, 4 times, etc. Another interesting part. Let's jump right to the clients I just mentioned at first. This is a, why is it empty? Oh yeah, yeah. It was just a cube, and I thought it was dull, so I removed it, and I planned to put something else, but now it's even duller. Like there's nothing. But basically, yeah, you can see the grid, and here you can see the avatar. So this avatar here is a div element, right? And here, they have the exact same, like almost the exact same. So here you can see the point of view of the other client, and on this, you can see the point of view of this user. So this is just simulating two clients that, but it works exactly the same way when you have like two, like or more users from different machines, basically.
Sorry, Houssem,
yeah.
Can you assign a viewport to a material within the render? Like having like a TP and a 3D scene, but it's actually using another viewport.
Can you repeat the first part? Sorry.
Can you assign like one of your viewports, but not render it here, and just assign it to a material into your 3D world?
That's in the roadmap. That's the under, but yeah, that's something that we want to do. Basically, use the rendering as a texture. So yeah, it's where is he? Yeah, here you have your. it's but yeah, it's an interesting feature. What else can I show? Like yeah, the overlays that are. So what you just saw, it's also was also an overlay. So here you have all the DOM elements I was just talking about, where you. Oh, there's something in this scene. Oops. Whoa. So yeah, it composes with the scene, but we don't have depth composition, so the DOM elements are always on top of the 3D scene. You can't even see where's my companion cube? Oh, it's here. Oops. And again, the code is very straightforward. You have your app layout, canvas, viewport, camera controller, and then you have all your DOM 3D elements that are very simple, basic HTML paragraphs. And you can put anything literally here. You can even put an iframe with another website, and it will show up right in the 3D scene. The 3JS overlay I was mentioning as well. So this cube is rendered with 3JS. Yeah, there's another cube inside. This is a test to see if it's completely overlapping, and it seems like it works, but there's the companion cube is inside. And here you have the multi-overlay that composes both, where you have, your DOM elements. You have your DOM elements, you have your 3GS cube over there, and your 3Dverse cube, the companion cube is like rendered by 3Dverse. And again, yeah, the WebGL doesn't compose depth. There's no depth composition with the 3Dverse elements, so yeah, it doesn't show quite well, but here the 3D cube is always on top of the 3Dverse element. And yeah, so maybe this one to finish with the finding entities. So here we have a scene with lights, as I just mentioned. So those widgets are connected to the entities on the 3D scene that represents the lights, those three lights. So this one connects with that one, so I can put it red, for example. This one green, etc. So you can really add your UI and very easily you can show the code. Very easily link it to your 3 elements. So here, for example, we have camera, blah blah. So you have your 3 lights, light 1, light 2, light 3, using the hooks I mentioned, use entity. And then in here you have on that div that disappeared, you have this light component, and the light component is the basic input with a color type and a slider and a reset button. And I don't know where, okay, this looks like it's not properly working. And yeah, that's basic. Oh yeah, the WebXR is interesting, like for people that didn't know. I have here installed a WebXR extension that simulates the fact that I'm in a Oculus Quest for this case. So if I click, so here it detects that I have an Oculus Quest, so it's VR. So I just click enter VR. It only supports VR, and now I can simulate the fact that I'm moving my head around. There we go. So you have your two eyes, and it's rendering in real time. And basically, if somebody is using a browser to access the same scene, another person is using a headset, they will see each other in the same scene, and they will see everything happening live. So yeah, let's. I think that covers. Yeah, I have. I think I'm. I don't know where my mouse is. Where? How can I go back to mouse? Where are you? Okay. All right. This should. Yeah. And I need to get my mouse back. All right. So there you go. So yeah. So that's our journey so far with React and with LiveLink React. So what's next here is like we started building another library, yet another library on top of LiveLink React, which is called like LiveLink React UI, which is your more usual component UI component library, where you have already built-in components that are ready to be paired with a 3D entity, for example. I had an example. I didn't show it, but a little widget with actually it's still here, I think, which basically facilitates the development of application with common patterns that you can have in a web app. So it's the very start of the library, so we don't have much. So this little widget right here is able to control if it detects that there's a sun in the scene. You can control the position of the sun. So you can in a nice little gizmo over there, and you can control whether or not it's casting shadows or not. And yeah, we are planning on going like putting everything open source. I mean everything. When I say everything, is like LiveLink React and LiveLink mostly. The protocol is not ready yet, but it's in the, like, let's say, long-term roadmap to put it open source as well if anybody wants to like dabble with it. And yeah, if you are interested, you can keep an eye on github.com/3dverse, or you can even register if you want, like to try it out on 3dverse.com, and then you just sign up and you have access to all the tools, or mostly all the tools that I just showed. My mouse is again lost in it's here. And yeah, I think that ends my.
What's the cloud native talk?
Thank you.